All right, so we are on day 5, and technically we're going to split this day across 2 days. Even though it says day 5 in your notes, we're actually going to do this today and in the next video. There's just a lot to talk about when dealing with quadratic equations, and since we just kind of finished up this unit when we were in school, I kind of want to take my time explaining everything. So I'm basically going to go through half of the questions today in your note packet, and then I'm going to save the other half for tomorrow. So if you want to hold off on doing like the homework that corresponds to this until you've seen both videos, that might make sense. Or if you want to challenge yourself and try it, that's, hey, great, that's awesome. So do whichever makes more sense for you. So when it comes to solving quadratic equations, notice now all of a sudden what we did yesterday, which was factoring, well, I should say in the last video was factoring. Now all of a sudden there's an equal sign, equal to y. To solve an equation graphically, you would bring up your graphing calculator, or bring out your graphing calculator, and you are going to type in your y equals screen the equation, so x squared minus 5x plus 6, and then you would go to your table of values, and you want to find that beautiful symmetrical rainbow looking table of values. But what I notice is it appears that there's 2 middle points, and we have learned that a quadratic can never have 2 middle points. That middle point is called the vertex point. And I've shown my students a few different ways to find this exact middle point. So I'm going to write my table of values off to the side. So again, the calculator is going to disappear. Hopefully you have it right in front of you on your own calculator. And I'm going to start by plotting these points. That's a 2, by the way. That's a 2. 2, 0. And remember, that was the one that seemed to repeat. So I'm going to skip a space. 3, Rika. Sorry, that's my dog. I'm going to skip a space. All right, so to find that missing number, we know it has to be perfectly halfway in the middle. So perfectly halfway between 2 and 3 is 2.5. So now what I do is I go to my calculator, I go and hit graph or zoom 6 so that we all look at the same window. And right next to the graph button, it should say trace. So press trace, and then I want you to type in 2.5, enter. Now, obviously, I'm not there to troubleshoot your calculator, so if you're getting errors, I would suggest pressing second plus sign, and then 7, 1, 2. If you hit second plus sign 712, what that does is just resets your calculator back to its normal, like, factory settings, and then you should have no problems. So second plus sign 712. It'll say RAM cleared, and then restart the whole question over again. You shouldn't have any issues anymore. So negative 0.25 appears to be the y value of my vertex point. So now I'm going to plot these points on my grid. So 0 up 6, over 1 up 2, 2, 0, 2.5, down just as little as quarter space, 4 up 2, and then 5 up 6. So I know I have a few students, my pen is awful and I apologize. Okay, there we go. I know I have a few students that like to use multiple colors, so let's label some of the characteristics of this parabola that we recognize. So we know that right at this peak right here, we call that the vertex. Okay, and that vertex was 2.5 comma negative 0.25. I know the places where it crosses, and then we also learned that for cubics might kiss, but in this case cross, we call those the roots. And we know that there is a line that cuts it right down the middle through the vertex point. Sorry, my line is terrible. Oh my God, that's awful. Sorry. Let's try that again. Let's try that one more time. Maybe it'll help if I do this. All right, let's see. That's a little bit better. That's my axis of symmetry. All right, now that that looks like a clown drawing, solving algebraically is when you take the equation, you set it equal to 0, and we learned 3 different ways to solve a quadratic equation. The first one is factor t-charting, which you should always try. If it's not factorable, then you've learned 2 other ways, completing the square and quadratic formula. This one, I would not complete the square because the middle number is odd. This one actually is beautifully factorable, and we actually kind of know the roots already. They're over in our table of values over here. So multiplies to 6, but adds to 5 would be 2 times 3, and both are going to be negative to create a 5. Now, unlike yesterday, because there's an equal sign now, I can actually solve for what we call the roots, solutions, zeros, or x-intercepts. Those are all synonyms that mean the same thing. So if you ever see find the zeros, find the roots, find the solutions, that it all means the exact same thing. Axis of symmetry, you can find this, obviously we found it in our calculator. You can find this by completing the square and putting it in vertex form. And it would be the x value of it. But then we also learned a little formula, x equals negative b divided by 2a. So in our original equation, our a value would be the 1 that's in front of the x squared. The b value is in front of the x, and the c value would be the 6 because our equation was in standard form. So when I find the axis of symmetry, it would be negative, negative 5. So negative, negative 5 is a positive 5 divided by 2 times 1. So that would mean my axis of symmetry is 5 halves, or 2.5. And that matches perfectly with what we graphed and what we found in our calculator. Before we move on to the next page, right at the bottom of your paper there, I actually want to write in an equation because you're going to see it on the homework corresponding worksheet. So I'm going to write in a picture. And on this picture, if you guys could draw the sketch of a cubic function. Okay, and what we want to do, what we want to determine on this is the equation, the possible equation for this cubic. You will have to do that on your homework. That's why I want to practice it here. So here's what I notice. This cubic crosses through -2, 0, and 6. So that means our solutions are -2, 0, and 6. All of them are crosses. One end behavior is down and one end behavior is up. So that tells me it has to be an odd degree. And I'm going to guess that this is a degree 3 polynomial because I have 3 solutions. So if it crosses 3 times, then I should have 3 corresponding factors. So if x equals -2, the factor it must have come from was x plus 2. If x equals 6, then the factor it came from was x minus 6. And then x equals 0 is kind of a tricky one, so that's why I included it. A factor of x would make a solution of 0. So this equation in factored form would be x plus 2, and then x minus 6, because if I was to t-chart that, okay, if I was to like loosely t-chart that, I should get these same 3 solutions that I see it crossing the x-axis. So this would be your final answer, not t-charted. But like I said, you're going to see that or something similar to that on your homework, so that's why I wanted to do that. All right, on the next page, it has solving systems of inequalities and quadratic linear systems. Since I did one of these the other day, I'm not going to do number 3. But I am going to do number 2. So notice that there are 2 separate equations. It says to solve graphically, but I'm going to use some of the space in the middle to solve it algebraically as well, just so we can like prove that our answers are the same. I'm going to graph the quadratic equation in red, and then I'm going to do the line probably in blue or green or something like that. So I would take out my graphing calculator, and I go to my y equals screen and clear out my old stuff, and I'm going to type in my new one, x squared minus 6x plus 6, second table, And lovely, I don't have to worry about finding a vertex this time like I did on the first page. There's my perfect window from 0 to 6. I'm going to jot those down in the margin because that's the work. So jot that down over here. 0, 6, 1, 1, 2, negative 2, 3, negative 3. Hopefully you can still hear me. Okay, 3, negative 3, 4, negative 2, 5, 1, and 6, 6. I don't know. There's buttons being pressed. I'm not really sure what's happening. Okay, let's plot these points. So 0 up 6, 1, 1, 2, negative 2, 3, negative 3. My dog is barking outside now. Alright, so here is my parabola. Remember, no shark teeth. Alright, and when you graph more than one thing, you have to label at least one of them. I don't care which one, but you have to label at least one. Alright, let me do blue for the other one. The other one's already in y equals mx plus b form, which is awesome. My y-intercept is negative 1, 2, 3, 4 with a slope of up 1 over 1. I can already tell what my answers are going to be. Alright, connect my line. So that's my second equation here. And my solutions are the places at which they intersect. So you have to tell me the solution points. One of them is 5, 1, and the other one is 2, positive 2, negative 2, because it goes over and then down. What we would do algebraically, if it said solve algebraically, so let me switch my color one more time, I'll just go to normal black, is because both of these are equal to y, I would essentially set these two equations, x squared minus 6x plus 6, equal to the other equation. And I would get that equal to 0, get it in standard form. So x squared minus 7x plus 10 equals 0, double bubble, x 5, x and 2. Both will be minus signs because it has to combine to a negative 7. T-chart it. I got x equals 5 and x equals 2. That matches perfectly with the x values of the 2 points that I found graphically. Then, to get the corresponding y values, I usually plug it into whatever the easier looking equation is, which in my head would be the bottom one. So the y value would be 5 minus 4. Well, 5 minus 4 is 1, so my coordinate point would be 5, 1, which checks. And the other equation would be y equals 2 minus 4. Well, 2 minus 4 is negative 2, which checks. So my equation would be 2, negative 2, and that checks the original equation too. Wonderful. All right. Completing the square. Now these say to solve by completing the square. So I'm going to do 1 today and I'll do 1 tomorrow. So I'll do number 4 today. And then I'm also going to do number 7 today and then I'll do 6 tomorrow. So I'm going to do 4 and 7 and then I'll save the other ones for tomorrow. So number 4, when it says solve by completing the square, notice it's equal to 0. We just got done completing the square when there's a y in there. If it's equal to 0, the steps are the same. You move the 12 over. And if you are in Miss Costanzo's class, I put a box. And I don't know what Miss Thayer does. I think she just leaves a space or an underlined space. Now to fill the box, we take the middle number, we cut it in half, and then we square it. So if I take the middle number and I cut it in half, which is 4, and then 4 squared is 16, that's the number I'm going to be putting on both sides. Well, this is going to factor to be 4 times 4 is 16, negative and a negative, because it has to be the same thing twice so that I can rewrite it as a single factor squared. And then negative 12 plus 16 gives me a 4. To finish solving for x, I square root both sides. So I get x minus 4 is equal to positive or negative, because remember you have to have 2 possible answers because it's an x squared. And the square root of 4 is 2. So now I'm going to set up my 2 cases. x minus 4 equals the positive 2, and x minus 4 equals the negative 2. So when I solve this one of my answers is 6. And when I solve this one of my answers is 2. Lovely. Completing the square. Wonderful. Quadratic formula. It's on your reference sheet. So when you get to your Regents exam, they will tell you on the reference sheet that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so as long as your quadratic is in standard form, you should be able to pull the ABC right off. So this would be your A, your B, your C. So let's fill it in. X equals negative b plus or minus the square root of b squared, so 8 squared, which is 64, minus 4ac all over 2a. And then I clean it up. And then that number underneath the radical, that's what I'm going to type in my calculator, but without the square root sign. So let me go to my home screen. It is 64 minus 4 parentheses 2 parentheses negative 15, enter. Oh, what did I do? Oh, minus. There we go. Enter. So 184 is the number that goes under the radical. Now, when we get to number 6, tomorrow I'm going to simplify the radical, but today the directions say round to the nearest hundredth, so I'm not going to waste my time trying to simplify that radical, even though it would have simplified. One of my answers I'm going to type in my calculator is that, and one of my answers is going to be this one. Now, I don't know if this calculator on my laptop can do alpha y equals. If yours can, oh yeah. Okay, perfect. All right, so this is negative 8 plus the square root of 184 all over 4. That's going to be one of my answers. Rounded to the nearest hundredth, that is going to be 1.39. And then what's going to happen is when I take this back out, let's see if it'll let me do this. Oh yeah, scroll up twice, hit enter, and then all you have to do is edit that plus sign to be a subtraction sign, and then hit enter again. And again, round to the nearest hundredth would be negative 5.39. Cool. All right, we're going to do one of these, so let's do number 8 today, and then we'll be done with this video. So number 8, it says complete the square to find the axis of symmetry and its vertex and define the roots. All right, so we're going to leave the y in there now. And step 1 is to add the 10 to the other side. And in its place on both sides of the equation, put a box. At least that's what I do. To fill the box, I take the middle number, so 4, cut it in half, 2, and then square it. So I put 4 on both sides. And I think you guys actually really enjoyed completing the square for this because, well, it's a lot quicker, I think, than solving. Multiplies 4 adds to 4 would be x plus 2 twice. So I'm just going to write it as a single factor squared. Get y by itself. And now you have it in what's called vertex form. If that's in vertex form, think in terms of transformations. This graph is being shifted. Let me change my color so you don't get confused. This is going down 14 and left 2. That's going left 2 and down 14. Whatever. Oh boy, oh boy, oh boy, oh boy. We have a happy parabola shifted left and down. It would look something like that. So if it's going left 2, down 14, our vertex point is negative 2, negative 14. Sorry about how ugly the 14 looks. There we go. And if the vertex is -2, -14, then the axis of symmetry is just the x value of the vertex point. The roots we just did on the last page, it's when y equals 0, so I would set this equation equal to 0. And I would add the 14 back to the other side. And square root both sides. You get a plus or minus in front of the 14. And move the 2 over. So you get -2 plus or minus the square root of 14. Those would be your roots. Obviously, they're irrational, so they wouldn't cross at a very nice place on the x-axis, but they're still technically considered your roots. Similar to what we did on the quadratic formula one, except that one we rounded, this one we left in terms of a radical. So we will complete all the rest of these tomorrow, well, in a couple days. Okay, bye.